Hi guys. So in the previous video, I went over the definitions of um, interval notation um, as well as just you know um, mostly like I said, interval notation, intervals, all that good stuff. If you guys did not catch that, it is on my YouTube channel. Okay, so now what we're gonna do is we're actually gonna do a good amount of problems regarding regarding writing intervals and interval notation. And I did do some problems like these a while back, and I'm just kind of going over them again because we are going to be learning about functions and all that good stuff within the next few videos. So, with that being said, we're going to go ahead and get started with this. So, it says write each interval in interval notation, then sketch a number line. So, not only do we have to write this in interval notation, but also sketch a number line for each of them. Now, so I think it goes, okay, so Part A tells us, and I'm going to go ahead and write it down. And it says the following, and it says -2 less than or equal to x less than 5. So, okay, so we need to write this in interval notation. Now, I know that when I'm given, so using my little table here, basically, the way that we would do this is we would go ahead and use one of these rules, right? Now, the rule that I would, use is basically, so we have, like I said, a less than or equal to x less than b, and that implies that this will be my interval from a, so bracket a, comma b. And like I said, you have to be careful when, depending on what your inequalities are, you have to be careful, because if you don't do it right, then of course they're not going to count it right. So in interval notation, this would be from, we're going to put a bracket at -2, so bracket -2, comma 5, and then parentheses. So that is how you do it in interval notation. Now to graph it on the number line, what I'm going to do is I'm going to go ahead and just kind of draw a number line here. So from -2 to 5, let's see, and I can go even a little more, so 7, 8. Like I said, it doesn't have to be perfect. I mean, if you already have it drawn, it's easier, but so so when we have a bracket, this implies that we're going to put a closed dot like this. So we're going to put it at -2, and then we're going to put an open dot at 5. So basically, it's going to go right here. And what you're going to do basically is just shade in between, right? So in interval notation, this is our answer, and this is how you would graph it, right, on the real number line. So that is part A. Now part B says the following, and it says -3 less than x less than or equal to 2. So -3 less than x less than or equal to 2. And again, if we have a less than x less than or equal to b, this implies that we're going to have bracket A, or I'm sorry, no, parentheses A, because it's less than, parentheses A, and then comma, and then B. Oh, and then B, and then close bracket, right? So basically, the way that this would look is, so we would have the following, and this is kind of how this would be. So, so we have -1, -2, -3, and I'll just kind of go a little more. So we have 0, 1, 2, 3, 4, 5, 6, so on and so forth, right? And the way that I would graph this, oh, and by the way, before we graph it, like I said, we have a -3 less than x, so I'm going to do parentheses -3, and then comma, and then I have a 2, so I'm going to do a 2, I'm going to put 2, and then close bracket. This is my solution in interval notation. Now to graph it, to actually graph this, we would then say, we would put an open circle. So remember, parentheses means open circle, so open circle. So we're going to put an open circle at -3, and then we're going to put a closed circle or a filled-in dot at 2. So we're going to put 2 right here, because this implies bracket and this implies parentheses, okay? Now all you have to do is shade it in between, so we're just going to shade in between. And that is how you do -3 to 2, right? So that is part B. Part C tells us 4 less than x less than 9. So I'm going to again do, so I have 4 less than x less than 9. And like I said, I'm going to write the rule down. So when I have A less than x less than b, this implies that my interval will be from A to B, but with both parentheses at both sides because it's less than, right? And again, when I do the graph, let's say here's A, so here's A right here, and let's say that over here is B, right? Now, at A, we have this going on, and we also have this at B, right? So we're just going to shade in between like that. So basically here, if I do it from 4 to 9, again, it'll be, so we have, let's do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so the first one says from 4 to 9. So the first one, so we have 4 less than x. So obviously 4 less than x less than 9. So it'll be from 4 like that, and then to 9. So we're going to go like this, right? And so just going to shade in between, right? Okay. And that is how you would do that. And now again, in interval notation, so interval notation, you would say parentheses 4, 9, close parentheses. So this is our answer in interval notation, and this is how you would graph it, right? Okay. Now, let's do part D. So part D says -4 less than or equal to x less than or equal to 1. So we have -4 less than or equal to x less than or equal to 1. And in interval notation, remember, we would say if we have a less than or equal to x less than or equal to b, this would be bracket a comma b, close bracket. So brackets at both sides because of this, right? So these imply brackets, right? So now in interval notation, if I write -4 less than or equal to x less than or equal to 1, in interval notation, this would be, hold on, this would be from, so it'll be bracket, and it'll be -4 comma 1 close bracket. So that is how we would do this in interval notation. And now to graph it, so I'm going to do another line, and we have, let's do, here's -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, etc. So we would start at from -4. So again, we have a bracket. So bracket again means closed dot. So we would say a closed dot over here. And then we also look at 1. So 1 also has a bracket, right? So we would put another one over here. And in between, we would just shade in between. Right? And this implies that our intervals from -4 to 1, and it's included. So always remember that bracket means included, parentheses means not included. Okay. Now part E says, so let's see. I think it's good. Part E says x is greater than 4. So we have x greater than 4. Now, this one implies that we need to do all values of x greater than 4. So here's how you would do it. And by the way, guys, I'm first gonna graph it, and then I'm gonna actually do the interval notation, because this one is a little bit different. So, gosh, we have something like this. Okay, 0, -1, -2, -3, -4, etc. Okay. So, the way that we would do this is, and we know that x is greater than a, right? When x is greater than a, the way that this would look on the number line is we would put, here's a, and the way that this would look is we would go ahead and say an open circle at a, and then going to infinity. So the way that this would look is that we're going to put an open circle at 4, and we're going to go all the way to the right. So basically it's just going to be shading to the right. Actually, I'm going to just go ahead and change that to that. Okay. And the way that we would write this in interval notation, so from 4, it goes to the right forever, meaning that we're going to have infinity right here. And remember I said that for negative or positive infinity, we don't put parentheses, right? You never put parentheses for negative or positive infinity, right? So the way that this would look, if I said that x is greater than a, then my interval in interval notation would be from a to infinity. So here, the way that this would be, x greater than 4 would then become parentheses 4 comma infinity. and this would be my answer in interval notation, and this is how you would graph it. Okay? Okay, so part F. Now part F says x is less than 1. Let me make sure. X is less than 1. Okay. Now, again, what I'm first going to do is graph it, because I want to see what this looks like before I actually graph it. Because it's, again, I don't like to, when it comes to these kind, I do not like to try to write it in interval notation first, because then it confuses the audience. I don't want to confuse you guys, so I'm first going to graph it. So we know that when x is less than a, the way that this looks is, here's a, there's an open circle, and we're shading to the left, because it's x less than a. All numbers x less than a, right? So when we have 1 here, here's 1, and the way that this looks, and I'm just gonna like kind of fill in the graph here. Okay. Now, the way that this would look is, we have an open circle at 1, so here's my open circle, and I want all the numbers that are less than a, so I'm going to go to the left, because those numbers are the ones that are less than a, right? So, the way that this would look, again, and now this here, so when I go to the left forever, this is negative infinity. It goes all the way to the left. So it goes to the left forever, and then it reaches a, and it stops right here. So what this tells me is that in interval notation, if I have x less than a, the way that this would look is negative infinity to a, not including a, so we would put parentheses at a. So here, in this example, x less than 1, well, in interval notation, this would be negative infinity to 1. And this would be the answer to this one. Okay. Then let's do part G. Is it part G? Yes, part G. Part G says x greater than or equal to 2. Okay. And actually, I'm going to change that. Okay, yeah. So the next part G, says x greater than or equal to 2, right? So we're just going to go ahead and write it down. X greater than or equal to 2. And when, like I said, when I have x greater than or equal to a number a, this tells me that I want all real numbers greater than or equal to a, right? So that's what this implies, right? So this one tells me I want all real numbers greater than or equal to 2, right? Now, how does this look in interval notation? Well, if I go ahead and, like I said, we're going to go ahead and just, I'm going to do a small number line here. 0, 1, 2, okay, 3, 4, 5, 6, so on and so forth. So here, what we're going to do is we're going to go ahead and so when you have x is greater than or equal to a, so basically we want all real numbers greater than or equal to 2. Again, the greater than or equal to implies that we are going to do a closed circle, or a dot, a closed dot. So here is going to be where we put our dot at 2, and then I'm going to shade to the right because I want all the real numbers greater than or equal to 2. So I'm going to do this. Okay, now the way that we would write this in interval notation, this is going to be bracket, and here's going to be parentheses. This is infinity. So the answer in interval notation will be from bracket 2 to infinity. And this is our answer for this one, right? Now, for part H, so for part H, we will say, and the way that this looks, let me see, hold on. How does this look? 2 less than x. Okay, so now this one's a little more tricky, right? Because it's not of the original form x is greater than a or x is less than a, right? So you have to see what direction this little Pac-Man thing or crocodile thing is facing. And like I said, here's Pac-Man here. Fun fact, but basically, you have to see where this is facing. So this implies x. So again, we're gonna kind of say, if I say, for example, a less than x, I'm saying that x is greater than a. You flip it over because this is the crocodile is eating the x, meaning that x has to be greater than a. It's like if I say 2 is greater than 1. Well, I know that 1 is less than 2. It's the same thing, and I went over this in the previous video. So this just means that x is greater than 2. You can rewrite it this way. And then what we're going to do is we're going to go ahead and kind of, so I'm going to define what this means. So basically I want all real numbers greater than 2, right? So, and so, so the way that this works is, and so I'm going to go ahead and say, so when I draw my number line here, so in my number line I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, so on and so forth. Now, all right, it's greater than 2. So again, when x is greater than a, I'm going to just show you guys really quick. So here's a, right? And we put an open dot here, shade to the right. Now this is x is greater than 2. So what that means is I'm going to do an open circle at 2, and I'm going to shade to the right because I want all the real numbers that are greater than 2. Now, to write this in interval notation, so basically we know that 2, so we know we have all the real numbers greater than 2. And again, it goes on forever. This is infinity over here, meaning that the numbers just keep going, right? I wouldn't call infinity a number. I would call it like, it just makes, I mean, yes, it's all real numbers. If all positive real numbers, really, and if it's negative infinity, it's all negative real numbers, but I wouldn't, it's a term, it's more of a term, it's not really a number. It just means that it goes on forever. Okay. Just wanted to point that out really quick. But basically, here, so we have an open circle at 2, so we're going to do 2, so it'll be parentheses, because when we use an open circle, it's parentheses, and we say 2, comma, and here's infinity, so here's 2 to infinity. And this is what, this means here. So basically, it goes from 2 to infinity because it's all the real numbers greater than 2. Okay. And I think, hold on, I think there was one more, so part I. So this is the last part. So part I says, and we are gonna do, so 3 greater than or equal to x. 3 greater than or equal to x. So again, I would simply say again, if a is greater than or equal to x, then that means that x is less than or equal to a. You just flip it over. Not the a and x, but like, you have to know this definition very well. It's like if I say 2 greater than 3, well, that means that 3 is less than 2. You know, they just crisscross. Okay, they make like an, kind of like that. Okay. So, here, the way that I would do this, and I'm going to go ahead and draw the number line first. I want all real numbers greater than 3. Greater than, oh God, greater than or equal to. Oh, I'm sorry, wait. Wait, no. Excuse me, I almost made a mistake there. This is going to be x less than or equal to 3. Excuse me. Like I said, you crisscross it. So then I want all real numbers x such that all real numbers less than or equal to 3. Okay, so then this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, so on and so forth. Now, again, and this is the last one, the greater than, or the less than or equal to, so basically, this is my original one, or actually, no, this is my original one, but it turns to that, right? And when x is less than or equal to a, obviously, we would say, and the way that I would do this is put a closed dot at 3. So like there's a closed dot there. And then finally, just, I want all the numbers that are less than or equal to that. So basically, again, like it says over here, I want all the numbers that are less than or equal to 3. So I'm going to go ahead and shade to the left. Right? Okay. So then this would be negative infinity. And like I said, when it goes on forever like that, it's negative infinity. And then here's 3. So again, when there's a closed circle, it's a bracket. So we're going to put a bracket here because that is the endpoint. Okay, so in interval notation, the way that we would write this is parentheses negative infinity to 3, close bracket. So this would be my final answer, and this is how you graph all of these. That is it for this video, guys. If anybody has any questions over this, please let me know. I know it was kind of a lengthy video again. I wanted to go over enough examples so that everybody knows how to do these. But if you guys do have any questions over this, please let me know. And also, thank you so much for watching, guys. And please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.